Okay, I will have a review assignment for you tomorrow to get ready for the test, so you'll be able to start working on it tomorrow, over the weekend, and Monday. Make sure you get your questions answered on Monday. Walk in here on Tuesday, get a good grade on that test. I will have a study sheet for you of the identities that you need to have memorized, and these are a couple of them that you'll need to have memorized. Okay, so Peyton, what is the Pythagorean identity? Okay, Hope, do you know? Okay, so we usually say sine squared theta. Okay, that is the Pythagorean identity. Okay, and I showed briefly how that works and why it works the way it does yesterday. If you have more questions on it and want to see why it turns out that way, we're actually a little more equipped to understand that today than we would have been yesterday. But that's sometimes called the fundamental trig identity. Okay, and then the reciprocal identities show the relationship between the trig functions. So the sine of theta is 1 over the cosecant of theta. Now, you could write it that way, or I'd take this. Cosecant of theta equals 1 over the sine of theta. Okay? One is implied by the other, so I take either one of those. That's the relationship between sine and cosecant. Those are reciprocals of each other. Okay? The next one would be that the cosine of theta is equal to 1 over which one? Secant of theta. Okay? Or an equivalent statement would be, just switch the places here, the secant of theta is equal to 1 over the cosine of theta. Okay? And then, of course, the tangent of theta is equal to 1 over the cotangent of theta, or equivalently, the cotangent of theta is equal to 1 over the tangent of theta. Okay? So there are 6 of them all together. I would know all 6 of them, and on the study sheet I'll show all 6 of them. You definitely want to have those memorized. But if you know this one, that one's kind of implied. Okay, so you could get away with that. Any questions there? If you've seen these before, they're less weird. If you just are getting used to these and haven't seen these before, they're a little bit on the strange side, but you do need to get them memorized. If you have questions about how they work and why they work, hopefully as we go through, they start to make more sense, but definitely ask a question if you're not quite sure. Okay, any questions so far? Okay, so there's a reason why I want to cover the first 4 sections, stop, take a break, review, and have a test on that, and then cover the last half of the chapter. Okay, it's because we're introducing all of the basic things, and then we get into some different aspects of this. So when we worked yesterday, nearly everybody in here, I would guess, has seen right triangle trigonometry, and you've been talked about opposite, adjacent, hypotenuse, and stuff like that. You've probably seen those things before. Okay, but because we usually graph things with x's and y's, and we normally solve equations with x's and y's, it's going to be much more useful in the long run to be talking about those trig functions in terms of x's, y's, and r's, because I don't just have to be stuck to the unit circle. I could be on any circle of any size, and I could have a point right here, x, y. If that point right there is x, y, I could drop a line straight down to the x-axis, and that's important that we always drop a line straight down to the x-axis, and I've formed a right triangle with an angle right here. Okay, from standard position. Remember, we start right here at 0 and we go in a counterclockwise direction. So there's a right triangle right there with an angle, and this point right here would indicate that this distance right here, we call that a radius. Point from the center out to the edge of the circle, that's going to be called a radius. Well, this side length right here, this horizontal one, would be the x-coordinate, x, and this is going to be the y-coordinate, y. So how could we write down a relationship for r squared, or better yet, what r is? How could I figure out r if I know what x and y are? Pythagorean theorem, right? So this is going to be x squared plus y squared. Or better yet, we really want to know what r is, so that would be the square root of x squared plus y squared. Okay, and the reason we do this, the reason we put things on a coordinate plane, is it opens up a whole branch of math called Analytic Geometry. So it sounds really weird, but you've actually been doing some Analytic Geometry probably in your other classes already. So if this is the angle that we're dealing with right here, this is an angle in standard position on for any point on the xy plane, we can kind of put the point here, draw the circle, and then we can think about it as kind of a stretch or a shrink of the unit circle. Then for that angle right there, the trig function, and we mentioned this a couple of days ago, the trig function for sine of theta would be the opposite side, which is the y-coordinate, over the hypotenuse. So this is going to be a y over an r. Now what was special about the way we did this before was the radius on the unit circle was a 1, so we didn't have to write that. Okay, so I actually wrote this on one of the notes a couple of days ago, but we didn't really dwell on it very much. Now we're ready to come back to that. The cosine would be the x over the r, and the tangent is just the same as we memorized before. It's the y over the x. So the reciprocal ones would be the reciprocal of each one of these. So the cosecant is the reciprocal of the sine, so that's going to be r over y. If you know the radius here, and you know the y-coordinate, you just take the radius, put it over the y-coordinate. That's going to be the cosecant ratio. This is going to be r over x. Again, just the reciprocal. And then this one is x over y for the cotangent of that angle. So we've still got those 6 trig functions. Okay, and these are still called the reciprocal ones. Okay, and we want to make sure that we memorize the identities that we've talked about and how these ratios are related to each other. Okay, what each ratio is and how they're related. Okay, so we're going to take a look at this problem right here. And it says, for the given xy pair, we want to find the sine, the cosine, and the tangent of the angle that's represented by that point. So this is a positive x-coordinate and a negative y-coordinate. So we're going to go over here, radical 3, and we're going to go down 1. 1 is a little bit less than radical 3. So here's our point on the unit or on the xy plane. So this point is radical 3 comma negative 1. Then from standard position, that angle would look like this. So there's the angle theta. And I want to figure out what the sine of that angle is, the cosine of that angle is, and the tangent of that angle. Well, let's put a line straight over here and let's make a right triangle. That makes this side right here radical 3. How long is this side right here? Okay, negative 1. Okay, it's 1 unit long, but we went in the negative direction. Okay, so the y-coordinate would be negative. And then how long is the hypotenuse? You recognize these? Take this leg and times it by radical 3, you get that one right there. Isn't this 30, 60, 90? So wouldn't this one be double? Or if we had to, could we use this right here? Wouldn't r equal the square root of the square root of 3 squared plus negative 1 squared? So if I put those together, I get this. If I square a square root, I get 3. If I square that, I get 1. So isn't this radical 4? And wouldn't that be 2? So I have all 3 pieces that I need. I've got the x, I've got the y, and I've got the r. So that means the sine of that angle is going to be the y-coordinate, negative 1 over the the radius of 2. The cosine of that angle, cosine for that particular point, is going to be the x-coordinate, radical 3 over the radius, which is 2, and then the tangent of that angle is going to be the opposite side over the adjacent, or the y-coordinate over the x-coordinate, so that would be negative 1 over radical 3. And again, we'd probably simplify that just a little bit by rationalizing the denominator. That's going to be negative radical 3 over 3. All of those should be things that you recognize. This is just a little bit larger version of the unit circle. In fact, the unit circle, if I were to draw the unit circle on here, would be right there. This circle that I draw here, what's the difference between these 2 circles? The size, right? This unit circle would have a radius of 1. This just has a radius of 2. but yet the relationships in those ratios turn out to be exactly the same. Okay? Any questions there? Okay, let's do this one right here. The point is -4, 3. So we're going to go back 4, and we're going to go up 3 to get to this point. What would the radius be? It would be 5. Because if you take that, square -4, square 3, this would be 16 plus 9, so this would be the square root of 25. So we get 5 for the radius. So I want, again, here's the angle from standard position. Here's theta. So we want the sine of theta, we want the cosine of theta, and we want the tangent of theta. So the sine is going to be the y-coordinate, which is 3, over the radius, which is 5. You write down the cosine ratio. Sven, what's the cosine ratio? It is very close to 4 over 5. What's not right about that? Okay, we went back 4 and up 3, so the x-coordinate is negative, so that should be -4 over 5. And then the tangent is going to be the y-coordinate. That's a 3 over the x-coordinate, -4, so that's -4/3. So there are the 3 trig values that we were after there. Any questions on that? Okay, raise your hand if you've seen that before. Okay, little less than those typical answers have been. Okay, so we want to make sure that we've got the right ratio, and like we pointed out here just a second ago, we want to make sure that it has the correct sign. And you can remember which trig functions are positive by remembering this statement right here. All students take calculus. So what we mean by that is all of the trig functions are positive over here. So if you start in quadrant 1 and then, like we do for an angle in standard position, go in a counterclockwise direction. So this would be all students take calculus. So they're all positive right here. The S in student stands for the sine would be positive here, the tangent would be positive here, and the cosine would be positive right here. So they're all positive in quadrant 1 because we're dealing with all positive coordinates. The x-coordinate is negative here. That's going to make anything that's involved with an x-coordinate or a cosine ratio, that's going to make that negative. The tangent is positive here, so the sine and cosine would be negative along with their reciprocals. And then the cosine is positive here. Okay, the other two would be negative. All right? Does that make sense? So let's think about this problem right here. It says if the tangent of theta is -5/12 and the cosine is less than 0, if we say the cosine is less than 0, we're meaning the cosine is what? Cosine is negative. So both of these are negative. It says find the sine of theta and the secant of theta. Well, let's figure out what quadrant we're in, because figuring out the ratio is pretty easy. Figuring out the quadrant sometimes can be kind of difficult. So if the tangent is negative, I can narrow this down just a bit, right? If the tangent is negative, it's not here and it's not here. It's either in quadrant 2 or 4. If the cosine is negative, which quadrants does it have to be in? Got to be in quadrant 2. So I've eliminated those three. I've got to be in quadrant 2. So we're in quadrant 2. And I need the sine ratio. So let's see. If the tangent ratio is -5/12, and this is the opposite side, and this is the adjacent side. I'm in this quadrant right here, so I'll draw a little triangle. Okay. Now, remember, there are 3 ways to write a negative fraction. You can write it on the top, you can write it on the bottom, or you can write it out front. It's best to make a decision here. If this is the opposite side on top and this is the adjacent side on the bottom, Which of these three ways is the right way to think about it? The first way, the second way, or the third way? This one right here. Okay? Because if you're in quadrant 2, this is the y and this is the x. Wouldn't we have a negative x coordinate and a positive y coordinate? So this would be negative 12 and this would be positive 5. Didn't we deal with these numbers before? A day or two ago? Anybody recognize those? If you square this, you get 25. If you square that, you get 144. If you add those together, you get 169. What's the square root of 169? 13. Okay? So that's a common Pythagorean triple. 3, 4, 5 is a common Pythagorean triple along with its multiples. And 5, 12, 13 is a pretty common Pythagorean triple. Okay? Once I have these sides, here's the angle in standard position. Don't I have the x-coordinate, the y-coordinate, and the radius? So I can figure those out, can I? I need the sine of theta, and I need the secant of theta. So the sine of theta is the y-coordinate over the hypotenuse. So that's going to be 5/13. Notice that we said the sine would be positive in this coordinate, and it is. Okay, now I need the secant ratio. Would you write down the secant ratio? Secant ratio is the reciprocal of the cosine. Cosine is the x-coordinate over the radius. We're going to do the radius over the x-coordinate. So you should have negative 13/12. Okay? So there are the two answers on this problem. Okay? Any questions? Okay. We're now going to just introduce some vocabulary and run through some relatively easy problems. Okay, we're going to talk about something called a reference angle, and we've actually drawn some reference angles and some reference triangles already, but it's important that you understand what this is. A reference angle is an acute angle formed using the terminal side of an angle and the x-axis. It is always the x-axis. Please don't draw triangles with the y-axis. Okay, make all your right triangles with the x-axis, or whatever the horizontal axis is called. Okay, and the way we denote this is theta prime. So if our original angle is theta, we call our reference angle theta prime, or at least this book does. Okay, and then we're going to talk about a reference triangle, which is something like this. Okay, so it's a right triangle drawn in the correct quadrant using the x-axis as one of the legs. And this is really important, so I'd put a star by it. The sides of the triangle must be labeled correctly with the correct lengths, so they should all be the right length, which we've done right here, and they should have the correct signs. The radius is always positive, but depending on whether we went right or left, the x-coordinate could be positive or negative, and depending on whether we go up or down, the x-coordinate could be, the y-coordinate could be positive or negative. Okay? Any questions about that? So reference angle and reference triangle, I'll show you more about those in just a second. So let me just come back and make sure we understand on this one right here. The secant is negative. Remember, that's not mentioned in our little phrase right here. All students take calculus. They're all positive here. Only the sine and its reciprocal cosecant are positive here. So that means the cosine, its reciprocal secant, the tangent, and its reciprocal cotangent, they'd all be negative. So only the sine and the cosecant would be positive here. That's why we've got a negative answer on that one. Any questions there? Okay. Let's take a look at this reference angle problem. Okay. It says the angle is 240 degrees, and we want to figure out what theta prime is. So 240 degrees, this is 90, this is 180. 240 degrees puts us right here. Okay. The reference angle is formed with the terminal side and the x-axis. So this angle right here is theta prime. If I drew a reference triangle, I'd drop a line straight to the x-axis. So it would look like that. I want to know how big this is right here. So if this angle from standard position is 240 degrees, how big is this angle right here? How big is theta prime? 60 degrees. Because I used 90 degrees, 180 degrees, there's 60 degrees left over for this one right here. Okay, let's take this one right here. A 30-degree angle. 30 degrees is right here. This would be theta prime. I could draw the reference triangle right there. If this angle from standard position is 30 degrees, then what would theta prime be? How big is that little angle right there? 30 degrees. So in quadrant 1, the reference angle is the same as the angle itself, as long as you've got this acute angle. Okay, now we're going to move into radians. Three pi fourths. So let's draw where 3 pi fourths would be. Again, this is why having that unit circle memorized is a good idea. 3 pi fourths would be here. That's our angle theta of 3 pi fourths. This is the angle we want. We want that angle right there. We want theta prime. So if this is 3 pi fourths, how much is left for this little sliver of an angle that's left over there? Wouldn't that be pi fourths? So that means theta prime would be pi fourths. And let's do 5 pi thirds. 5 pi thirds. So there's a third of pi, there's 2/3 of pi, there's 3/3 of pi, there's 4/3 of pi. 5 pi thirds right here. So there's theta, and we want theta prime. We want to know how big that angle is right there. If I've used 5 pi thirds, what's left for this one right here? Be pi thirds, right? Okay. Any questions there? Okay, now we're going to go through a table that's in your book. I'm not a huge fan of this. Okay, I would much rather you figure out what the reference angle is by looking at it and thinking your way through it, but they've got these little rules and I suppose they could be helpful. Okay, so if you're in quadrant 2 and you know theta right here, how do I figure out how much is left for this one right here? Like on this one, if this whole angle is 3 pi fourths, how do I figure out what that one is right there? Let's say that was 135 degrees. It might be a little bit easier to figure out why that's 45. You take 180 and you subtract that. So if you're in quadrant 2 and you know this angle from standard position right here, in degrees you're going to take 180 degrees and you're going to subtract theta. So this side right here is 180 degrees. If you subtract what you originally had, that's going to give you this reference angle right here. In radians, that's going to be pi minus theta. Again, I'm not a huge fan of this, but I'm going to show you because it's in the book. If this is theta and we're in quadrant 3, how do I figure out how big this little angle is that's left? How do I figure out what that reference angle, theta prime, would be? Subtract 180 from the angle, right? Because the angle's bigger than 180. If I subtract 180, that's going to tell me what's left for this guy right here. So we're going to take the angle and we're going to subtract 180 degrees, or in radians, we're just going to subtract pi. And how about this one? See if you can figure that one out. I want to know what's left for this theta prime right here. If I've got this whole thing, how do I figure out what's left? Who can tell me what it is? Noah? You got it? Anybody? Let's say this was 340 degrees. How big is the reference angle? It would be 20 degrees, right? That's what's left over. How could you take the whole circle and figure out that you've only got 20 degrees left? Okay, so we're going to do 360 minus the angle, or 2 pi minus the angle. Okay, here's how I like figuring out problems like this. Okay, so look at example 4 in this box right here. Here's each one of the angles theta, and they want you to figure out what theta prime is. What's the reference angle? I would much rather do this. I'd rather think about, well, negative 195. Negative 195 is here. I used 180 degrees right here, so I'd subtract 180 from the 195 right here, and that would give me 15 degrees left over. That would lead me to theta prime being 15 degrees. Does this little rule here work? Look at it. 180 degrees minus, what's the measure of that angle? Minus 195. Those two would add up to something that's bigger, wouldn't it? Okay? So I'm not a huge fan of these because they only work if the angles are between 0 and 360 or between 0 and 2 pi. They don't work for negative angles, and they don't work for ones that are bigger than 2 pi. Okay? So again, not a huge fan. I'd much rather you draw these and think about what they look like. Okay? That's why we took the time to go through and figure out roughly how big each one of these is. Whoops. I'd much rather you be able to figure it out that way. So let's think about 4.2. 4.2 would be, well, that's 1.57. That's 3.14. That's 4.71. So we'd be right here. We'd be in quadrant 3. How do I figure out how big that angle is right here? Well, I take off this piece right here. I take off the pi. So we're going to take 4.2 and we're going to subtract pi, and that we'd want to do on the calculator. So we're going to do 4.2 subtract pi. 1.058. Does the size of this angle right here, does that look like roughly 1 radian? Roughly 1 radius? Does to me. Okay. Notice this angle is bigger than 360 degrees. So think about where that would be. 420 degrees. There's 90, there's 180, there's 270, there's 360. How many degrees do I have left over? So on this one, you actually take 420 and you subtract 360 because you've done more than one full circle around. So subtract 360 and I get theta prime on this one is 60 degrees. Okay, would you do the last one, please? Isn't that 2 1/3 of pi? Yep. So our reference angle in this case is going to be pi thirds. Okay? Isn't 7 pi thirds the same as 420 degrees if you converted it? Okay? You're going around the circle one full revolution, 2 pi, and then another third of pi. So that angle right there would be pi thirds, 60 degrees. These two problems right here, they're the same problem. Okay? Again, I would not spend any time memorizing these right here. I would understand the idea. Figure out what quadrant you're in, and then figure out, based on whether it's positive or negative, how big is that little sliver of an angle that's left. Okay? All right, we're going to finish this tomorrow. You should be able to complete this table. Don't do it yourself, but you should be able to look at that and figure out what's the radian equivalent of each one of these, and what would each one of those ratios be. Okay? You're going to need to have that memorized for the test. Okay, have a great day.